So on that first video, we just came up with our formula for volume of a prism. We said that that formula is volume equals area of base times height of prism. So it's really important to indicate what is your base. That'll tell you which formula to use for your area. That could be a rhombus, it could be a trapezoid, it could be all kinds of things. All of those formulas from chapter 11 we have to remember. And then the height, remember, is always the distance between bases. So I've got these two examples here. They're both regular hexagonal prisms. Some people say hexagonal. There's nothing wrong with that. I say hexagonal, just my accent. So here I have my prism. My base is supposed to be a regular hexagon. So that tells me this front face and this back face are what we call the bases. So what that's going to tell me is my height, being the distance between bases, should be this 10 meters. That's my height on this one. The height is not this up and down distance, it's the distance between my bases there. Okay, so this is a regular hexagon. One side of that hexagon is 6, so this is a chapter 11 type of question. I'm going to go ahead and copy that hexagon down here. Oh wow, that's beautiful. Oh my gosh, I'm embarrassed. Anyways, you get the idea. We draw our right triangle, we find our angles. So if this is 6, this little piece will be 3, and remember to find your apothem of this thing. If this is a regular hexagon, each of those angles is 120. We've seen this about 100 times now. That means that this radius will bisect that to be a 60-degree angle. Oh look, another 30, 60, 90 triangle. The pattern is opposite 30 is the short leg, opposite 90 is double that, so the radius of our hexagon is going to be 6, and then the apothem is going to be 3 square root of 3. So little a equals 3 root 3. So what we need to do is find the area of our base. So area of our base is going to follow the formula 1/2 perimeter times apothem. So that's going to be half of, if our base is a regular hexagon, all sides are 6, then the perimeter, 6 times 6 is 36, and then that apothem is 3 square root of 3, and let's see, I could take half of that and then multiply by 3. You should get 54 square root of 3 square meters. So there's the area of our base. Now this isn't an area question, it's a volume question. Now all we need to do is do area of base times the height. And that comes out to 540 times the square root of 3 meters cubed. Because now we're counting cubes, we're no longer counting squares. So that's how we got the volume of this thing. Again, volume measures how much space or how many cubes would fit into there. Exactly this many, 540 times the square root of 3. I don't know what that's going to be as a decimal. You could use those calculators to find that out. Okay, so this next one's a little different because it looks like it's sort of like tilted a little bit. All right, so does it have the same volume formula? I have a little kind of visual aid to help us out on this one. So here what I'm going to do is look at a cylinder. I have a stack of quarters, and that stack of quarters forms a cylinder. So I can see the volume of this thing. I can look at the height. I can see how many cubes fit in there. And again, volume is how much space. So looking at how much space these quarters take up, I could record that if I wanted to. Now, if I move this and kind of tilt it a little bit, where it looks kind of like that hexagonal prism, I know it's not perfect. Maybe I can make it even more tilted without tipping. It's going to tip over. Okay, so now my cylinder is kind of slanted like that. The question I have is, does this stack of quarters take up any more or less space? The answer to that should be no, because I haven't added any material or taken any material away. I've just rearranged where all of that material is. What this is called is an oblique solid. So I'm going to write that down. So this is something called oblique. What does that mean? It means it's slanted, it's tilted, but should have the same volume. Now the surface area is going to change. We're not going to look at that, but the volume will not change. So since it has the same volume, we still need to figure out what is the perpendicular distance between bases. That is going to be our height. So this one looks really hard, like a difficult question. We just saw another regular hexagonal prism. That was kind of annoying to find the volume. But this one is actually pretty much all done. They're telling us the area of our base is 17.3 square centimeters. And this right here is our height, because that is the perpendicular distance between our bases. Even though they're tilted, they're not exactly like lined up. They are parallel and they are congruent. They're just kind of tilted away from each other. So volume on this one, area of base times the height of my prism, is going to be 17.3 times 6.4. Oh gosh, and I don't have my calculator on me. I'm going to find it somewhere here before I post my next video. But you go ahead and put that into your calculator, see what you get, and make sure your answer then is centimeters cubed. So you do want to multiply that out, use those calculators to get those. So I'm going to stop here and then post some more videos of cylinders and some other prisms.